Okay, this video is covering Unit 5, Lesson 3 of how we're studying this material this year. I have taken bits and pieces of two sections of our book, which is why, again, that I'm putting that heading at the top. But basically what we're doing in this lesson is talking about graphs, graphing, exponential, and what you're soon to find out, logarithmic equations. Okay? So, to refresh your memory, remember repeated addition can be represented with multiplication. 5 plus 5 plus 5 is the same thing as 5 times 3. And repeated multiplication can be represented with exponents. Okay, so we are going to be talking about our exponential function. And I realize that we have talked about this in the last two lessons, okay? But what is different about this one is we are talking about the parent function. And as we have discussed earlier in our previous units, okay, the bare bones of it is going to be y equals b to the x, okay? And we've discussed this before, that b has to be greater than 0, can't have a negative value here, and b cannot be equal to 1. Okay, if you have questions about that, come see me. Okay, so, and every time that we've done graphs in this class, we always talk about our key points, okay, and a quadratic function that we've talked about. Okay, quadratic looks like a U, okay, and our key points were 1, 1, 2, 4, 3, 9. But we used those key points to graph, and then we just saw what changes we had to the graph. We knew the general shape, and then we knew the changes. Okay, so that's the exact same thing that we're going to continue as we do our exponential function. So first off, we can have b being greater than 1, which we've talked about numerous times. That is, of course, going to be growth. Or our b could be less than 1, but of course it has to be greater than 0. And that would be decay. But both of these graphs are going to have the same key points. Now, what are those key points? They're going to be, and this time, instead of writing them across, that's probably why I generally go 1, 2, 3, 1, 4, 9 for our quadratic. But for exponential, -1, 0, and 1. And then I keep going around because this is b, and this is 1, and this will be 1 over b. So both of these graphs have a y-intercept of 0, 1. The growth is going to get bigger and bigger, and the decay is going to get smaller and smaller. Okay, so that's, of course, depending on your b value. Okay, now we've also talked about asymptotes. Okay, so remember, it is on both of these cases the x-axis. So this is my asymptote for each of these. All right, so what is my domain? My domain is farthest to the left, and that is, of course, negative infinity. Farthest to the right is positive infinity. My range is the lowest value, and remember this value goes closer and closer because it's an asymptote. It's getting closer and closer to the number 0, but it never touches 0. So that's why it's parentheses and then infinity, because that's the lowest that it goes is 0, and the highest that it goes is positive infinity. My intercepts, as I said, are always going to be 0, 1, and asymptote is always going to be y equals 0. And I often write that on a graph if I can't see when you draw it. Sometimes if it's the x-axis and you can't see it, then I write it next to it because that reminds me that that's going to be an asymptote. Okay, now, is it going to be this for every graph that you do? No, but it is for the parent function. So that's what you need to remember, because now we're going to figure out how to apply that. So let's go get busy. So the first one we have, y equals 4 to the x. So when you're graphing these, the first thing that you want to do is figure out what your b value is. So my b in this problem, and b, of course, is always going to be whatever number has the exponent attached to it. So in this case, b is equal to 4. And you always want to write down your asymptote because that's going to be something that's going to help you do your graphing. So b is 4, my asymptote is 0, my key points, -1, 0, 1, 4, 1, and 1 over 4. So I prefer to graph my asymptote first, so I'm going to go put that on there. It does need to be dotted. It is not part of the equation. It's not part of the graph. It's just something to assist us in graphing. So whenever you do, you need to make sure that you dot it. Okay, so -1 is 1/4, and when you graph that, just estimate it's less than 1/2. 0 is at 1, and 1 is at 4. Okay, so when I connect these, I'm going to approach this one like an asymptote, and then I'm going to go up. Now, when you get here, make sure that you don't do something like this, because then you're telling me that this point, which is 2, 7, is on the graph. If I put in 2 here, do I get 7? Well, is 4 to the second power equal to 7? It's not 7, it's 16. So that's why you don't want to make sure that you graph past that. At 2, go away. At 2, it's actually way up here at 16. So when you graph for me, just either extend it like that. If you want to go all the way in there and connect it, you can, but you don't have to. Okay? But more importantly, don't cross this over to 2 if you don't know what that number is. Okay? I think that will help in your understanding if you can understand what I just said. And if not, come see me. I'll be happy to help you. Okay, so look at the next one. First thing we want to do is figure out what B is. And B in this case is 1/3. My asymptote is always y equals 0 until I get something different. Key points, -1, 0, 1. And then B is 1/3. And then 1, and then 1 over B. Well, 1 over that number is the reciprocal of that number, so I just flip it. Okay? So again, I'm going to start off graphing my asymptote, y equals 0. And now at -1, I have 3. At 0, I have 1. And at 1, I have 1/3. So again, I'm going to graph it. Now this part, when you're getting close to the asymptote, that's fine. It's the other part. So you can either figure out what goes here or just stop. And if you put in, if I keep going this way, this is 1 and this is 3. The next power of 3, 3 times 3 is 9. That's the next number. If you don't understand that, I don't like the way that looked. If you don't understand that, then you can just stop the graph there and you'll be fine. Okay? But just know that you don't want to cross it if you don't know what that point is. Alright, so moving along. Let's go with y equals 2 times c to the x. Something a little different here. We got an extra number in there. But first thing you always want to do is still figure out what your b is. And b is the number that has the x in the exponent. So b is 3. Okay? Asymptote y equals 0. And I want you to go ahead and write the key points down because I don't want anything to confuse you from those key points. So that's 3, 1, and 1/3. Now I go back and I say I got another number in here. That's a 2. This is where we're going back to what we did the first 9 weeks. That 2 is outside or inside the parentheses. It is outside. So if it's outside, then we know that it affects the y. And it affects the y, we do the same thing that what it looks like in the equation. 2 times. So I'm going to multiply. And if you remember when we talked about it, that's what we call a vertical stretch. So each of these y values is going to be multiplied by 2. That looks like a times 2. Multiplied by 2, not a decimal. Okay? So my x values don't change. 3 times 2 is 6. 1 times 2 is 2. And 1/3 times 2 is 2/3. Kind of having a hard time squeezing that in. Okay? So, those are my points. Again, now, this I did it to every y value, and my asymptote is y. So I need to go do the same thing to my asymptote. 0 times 2 is 0. So did my asymptote change this time? It did not. I still have y equals 0. Alright, and I'm going to plot -1 2/3, 0 2, and 1 6. Okay, I don't want to plug in 2. I don't want to find out what 2 is. So I'm just going to keep going, but I could tell you if you want to know, come ask me. I'll be happy to do, because if you do understand, it makes it a little bit easier. So we'll just graph it like that. Okay, 2 more on our exponential. Just adding a few more changes to it so you can see. All right, so how does the graph of each function compare to the graph of the parent function? We're going to graph it to find out. All right, so what do we do first? I hope you answered. Find out what b is, and b is 4. And second, I'm going to write down my asymptote, y equals 0. And then I'm going to go write my key points. -1, 0, 1, 4, 1, and 1 over 4. And then I go back here and I say there's a 2 in there. And what does that do? It's inside the parentheses, so it affects the x, and most of y'all know that goes to the left. So if it goes to the left, what am I going to do to each x value? I'm going to subtract 2. So if I subtract 2, -1 minus 2, -3. 0 minus 2, and 1 minus 2. My y values do not change. My asymptote, y equals, I did something to the x's, not to the y's, so again, it will not change. So my asymptote is still y equals 0. So y equals 0. At -3, I have 1/4. At -2, I have 1. And at -1, I have 4. Okay? So as I keep going here and go up, now what is 0? And some people might get this, so I want to tell you, if b is 4, then each time I'm multiplying the number by 4. 1/4 times 4 is 1. 1 times 4 is 4. 4 times 4 is 16. That's the next number, which is way off my graph, so I'm not going to put it on there, as we've talked about. Okay, last one for exponential. Again, first thing, b equals, now this says 0.25, and I would encourage you to not put 0.25 because you're going to have to take the reciprocal of it over here. So 0.25, everybody knows, is 1/4. Still have y equals 0. All right, and so I'm going to go write my key points. We're just going to do it right here. -1, 0, and 1. And that, of course, is 1/4, 1, and then 1 over 1/4. I just flipped it. So now I'm going to go back here and say, does that affect the x or the y? It's outside, so it affects the y, and I'm multiplying. And this 5 is, again, outside, because this is what it looks like when it's inside. It's inside those parentheses. And so I think y'all are really good at telling me that moves up. So keep in mind, I have 2 things happening to my y, because obviously if I move up and down, that's my y. I have, I'm multiplying and I am adding. So the question is, does it matter which one you do first? And of course it does. But just remember that you want to follow your same order of operations. So each y value is going to be multiplied by 5, and then you're going to add 5 to it. My x's do not change. -1, 0, 1. So 1/4 times 5 is 5/4. Plus 5 is 6 and 1/4. 1 times 5 is 5. Plus 5 is 10. And 4 times 5 is 20. Plus 5 is 25. Okay? Asymptote is y equals, I did these to the y values, so I got to do the same thing. 0 times 5 is 0, plus 5 is 5. So this is an example of one where we have a new asymptote, and our asymptote is at 5. That's pretty bad. See if I can make that better. A little cockeyed here. 5. There we go. All right. And so then I'm going to plot my points. And when you plot them for me, y'all, 0, 10 is right here. 6, 1 is 6 and 1/4. And then -1 is 25, which is way up here. So just, you got the idea, and make it approach your asymptote. So don't go below the asymptote. That was not good. And then you're good. Okay, so this is a great stopping point, but this is what we covered the first day because of the way my days felt this year. Fell, not felt. Anyway, it's a great stopping point. However, when you get into the next one, okay? So to go into the next lesson, sometimes, or what happens if I take a function, okay, we've had, or what we started with, we had y equals 4 to the x, okay? What if I changed that and I said solve x equals 4 to the y, and you have to solve that for y, okay? We don't know how to do that, okay? But what I just did, all I did was switch my x and y. And if I switched my x and y, and it was kind of like the problem that we did with graphing and the interest, when we had to solve for that variable. We're trying to figure out what this is, okay? So to be able to solve that, okay, we're switching the x and y's. And if you remember from earlier lessons, when we switch x and y, y'all remember what that's called? Hope you're thinking on your toes. We get inverses, okay? We get inverse functions of each other. So that is how we come up with something called the logarithmic function, okay? A logarithmic base b of a positive number satisfies this following condition. But more importantly, you need to remember that these are inverse functions, exponential and logarithmic, because it is defined like this. If you have the log base b, okay, give me 1 second. I'm having some technical problems. Hold on. Okay, I think I got that fixed. So the log base b, actually, let me start with y. Y equals the log base b of x if and only if b to the y equals x. Okay? More importantly, y'all, this is a definition, okay? Not necessarily something, just like we've talked about before, a desk is a desk. How do you know it's a desk? Because somebody told you it was. It's a definition. Not much to understand, except for, as I just explained, where does it come from is we switch the x and y in an exponential function. Let me tell you this little thing because this helps people remember. If you write this a little differently, okay? Log base b of x equals y. So when you look at it that way, they like to remember this little kick out. Somebody goes, that's the boot problem. Because when you start down here with the base, b to the y equals x. Well, that's what that says right there. So that's another way of how to remember how to go back and forth between an exponential function and a logarithmic function. Okay? And they are inverses of each other. Now, the only thing that we're going to do today is talk about graphing them. Okay? We're going to learn a lot more about them later on. But right now, let's talk about graphing them. So, the key points. How did we get this? We switched the x and the y. So now, instead of my key points being negative 1, 0, 1 on the x, they're going to be negative 1, 0, and 1, and my b, 1, and 1 over b. All I did, okay, as I just said, we switched the x and the y. Same kind of thing, okay? B is greater than 1, or b is less than 1, but again, cannot be less than 0. So what's going to happen, if you notice, my intercept now is not at 0, 1, it is at 1, 0. And this is what the growth one is going to look like. Okay. And again, 0, 1 is still going to be 1, 0. And this is what the non-growth decay. Okay. And hopefully you're already telling yourself what the asymptote, instead of x equals 0, it's going to be, instead of the x-axis, it is now the y-axis. So, what is my domain? My domain is, so again, we switched it. So what did we have for the exponential function? If you want to take a peek back and look, all right? What did we have? We had, this was the domain, and this is the range. So if we're switching the x and y, then those things are going to switch. So, to fill them in, my domain now is from 0 to infinity. And you can see that from our graph. I don't ever go past 0. You cannot take the log of a negative number for that reason. The range is negative infinity to infinity. Switch that, so it's not 0, 1 now, it's 1, 0. And my asymptote is not y equals 0, but x equals 0. So we're going to be using the same things we've just been doing, but things just got flipped. So if you know the exponential function, then this one will be a piece of cake for you. All right, one thing you do need to know, especially when you come across a graph, and if you see no base is written, y equals log base x, then you need to know it is understood to be base 10, and it is called the common log or common logarithm. Okay, so let's go graph a few, and then we'll be done. So what is the graph of y equals log base 4 of x? Describe the domain range, y-intercept, and asymptotes. Okay, that's how I start off anyway, so that won't be an issue. But just like we've been doing, y'all, first thing you want to do is identify your base. What is the base? It is 4. What is the asymptote? X equals 0. Okay, and so I'm going to have my key points. We used to do them down here. Now we're going to start over here. Negative 1, 0, and 1. And then b, 1, and 1 over b. So I'm going to go graph my asymptote, which is right here. X equals 0. And my key points, at 1/4, I'm going to be at negative 1. At 1, I'm going to be 0. And at 4, I'm going to be 1. So as we kind of keep talking, you might be able to figure out that next number again is not, I'm multiplying by 4 every time. Times 4 times 4. And so this next one is going to be way over there. Okay, 16. So we don't have to graph it. So, and I totally missed that. All right, graph it like that. Don't go past the 2. Try to get your dots. Do a little bit better than I do. And then it approaches it asymptotically. Okay, that was a fancy word for asymptote. All right, so what's my domain? Okay, it didn't change. 0 to infinity. What's my range? Negative infinity to infinity. What is my y-intercept? Oh, y-intercept, y'all. No y-intercept. That's what I say. No y-intercept. Because my asymptote is x equals 0. So there we have it. Okay, 2 more and we're going to be done. Which means if you only listen to the logarithmic part, it's not very long. Okay, so we're going to do the same thing that we've been doing, just like we did with exponents. So start off with, what is my base? Base is 2. Asymptote starts off with x equals 0. So my key points, again, so you can kind of think of it, y'all, whatever your asymptote is, you start on the other side with your key points. Negative 1, 0, 1, 2, 1, and 1/2. So we have that much so far. Then I'm going to go back and look at these numbers and say, ooh, that moves it to the right. And this one moves it up. So if I move it to the right, what am I doing to each x value? That means I'm going to add 3 to each x value. And if I move it up, I'm going to add 4 to every y value. So 1/2 plus 3 is 3.5. 1 plus 3 is 4. And 2 plus 3 is 5. And then I'm going to add 4 to each of these. So negative 1 plus 4 is 3. 0 plus 4 is 4. And 1 plus 4 is 5. Okay, my asymptote was x equals 0. So what did I do to each x value? I added 3 to it. So I'm going to add 3. And 0 plus 3 is 3. So graph my asymptote. My 3 is right here. And then I'm going to plot my points. So at 3.5, 3.5, I'm at, and it's messing up on me. Don't do that to me. 3.5, I'm at 3. And at 4, I'm at 4. And at 5, I'm at 5. Okay, so this is my asymptote, so I know that I'm going to approach it like that. Okay, that was really bad. Sorry. Let's go with, let's do that. Okay, and that's good. Domain is, actually our domain now starts at asymptote, y'all. So my domain is 3. I'll go ahead and write that down. Okay, our domain is 3 to infinity. My range, negative infinity to infinity. My intercepts, I'm not going to go there. And my asymptote was x equals 3. You could put in, okay, we'll stop there. That's good. All right, so last one, y equals 5 log base 2 of x. That's how we say that. So to graph that, again, what's my base? Base is 2, x equals 0. So key points. If I have x asymptote, then I start on the other side here. So base is 2, 1, and 1/2. And what does that 5 do? It is going to affect the y. It's a vertical stretch. So I'm going to multiply each of my y values times 5. And that's going to give, so my x's don't change, 1/2, 1, and 2. My y's become -5, 0, and 5. And x equals, my x's didn't change, so my asymptote will not change. So I have, alright, so that gives me, and if I plot those points, then I have 1/2, -5, and this is where that vertical stretch is coming in. At 1, 0, and at 2, it's 5. So we're going to, this is the asymptote. Golly, that's terrible. Okay, I might grab that at the end though. Let's talk about our domain. Our domain, okay, I didn't shift anything left and right, so it's still 0 to infinity. My range is -infinity to infinity, and my asymptote is x equals 0. Okay, yes, I have a y-intercept, excuse me, an x-intercept of 1, 0, and I have no y-intercept. Okay, so I'm going to try to one more time to graph it, and if it's not good, we're just going to stop, and that's terrible. So I am going to let you go. I will fill it in if you need a hard copy of it, but you know how to connect the dots. And if you have any questions, please come see me. In class, we did fill in our parent function packet, so make sure that you put the key points of your exponential and logarithmic function in your parent function packet. Okay, all is well. It's good. If you have any questions, please come see me.